This is my stepper motor control circuit. It is designed to control bipolar stepper motor. The circuit consists of an NPN transistor, right here, an astable NE555 oscillator, and a PIC 16F84A microcontroller and a potentiometer as well. The code for the microcontroller is written in assembly. As it is now in its current state, the circuit lacks two crucial components, meaning that it lacks two H-bridges. One of the H-bridges should be where these LEDs are, and the other should be where these LEDs are. I've used LEDs because I wanted a visual representation of the pulses which would make the stepper motor rotate. I thought that visual representation would be interesting in terms of learning more about the principle of operation of the circuit while making it more interesting during the process of building, and that's why I am filming it in this condition. As I said, the NE555 is configured in an astable mode, and it creates pulses which control this NPN transistor right here. The pulses turn the transistor on or off, and using this PIC here, I am digitally reading the voltage present at the collector of the transistor. When the transistor is on, meaning it's saturated, the voltage at the collector is 0. But when the transistor is blocked, when it's off, the voltage at the collector is identical to the power supply voltage, meaning in digital language that it is a 1. And when the microcontroller here reads the correct number of pulses, it activates the correct sequence of ones and zeros, which would power up the correct windings for the correct step of the stepper motor. For example, when the microcontroller counts one pulse, it activates the combination of ones and zeros for the first step of the stepper motor. When it counts two pulses, it activates the combination for the second step of the motor, and so on up to 4 pulses, after which it reverts to 0 and starts counting again. Now I'm going to turn on the circuit and make a visual representation of the pulses which would power up the stepper motor I am planning to use. I am going to turn on this battery here. Yes. This is the circuit oscillating. The NE555 oscillates. The PIC microcontroller counts the pulses that the NE555 outputs, and according to the number of counted pulses, the PIC activates the corresponding sequence. Using the potentiometer here, I can change the duty cycle and make the blinking of the LEDs much faster. Now I'm going to turn the potentiometer, and we can see that it is oscillating at a higher frequency, and I can decrease the frequency of oscillation like this and make the LEDs blink slower. The stepper motor I am planning to use is salvaged off of a laser printer. The final version of the circuit will include two fully functional H-bridges and a stepper motor connected to the H-bridges. I'm going to ramp up the frequency again, like this. Yes, we can see now that it blinks faster. I'm going to decrease the frequency. It blinks slower. If we were to have a real stepper motor connected where the LEDs are and a real H-bridge where the LEDs are, right now the stepper motor would have been turning slowly. And if I increase the frequency again by turning this potentiometer here, yes, the stepper motor would have been turning much faster. I will decrease the frequency again. So that's all. Thank you for watching.